Hey everybody, we're getting started right here. We're going to start with some 474. Let me turn off the stream in the background. I see Dan is here and Alyssa's here. Let's get started and hop over here. Let's do it. 20 Point Tuesdays. Let's bring up the regular bumper right here. Good to see you here, Dan. After you help Alyssa, can you help me with the quiz? Sure. Which one are you working on? Put the problem in the chat. We'll get working on it. Hey, Gigi, how are you doing? Put any problems you want. We'll work on it. Woo! I need some water. Turn on the air right here to get it cool. Hey Brian, could you go over 2B? Yeah, let's start on question 2 a little bit. Let's talk about it. So, because that's what people are asking about. We have here tenure, checking balance, saving, and all of this is being loaded from the account data set. And this is whether or not somebody makes a purchase. So we're going to load up here library reg class. We're going to load in the accounting data and we can take a look at it. So these are all the variables right here. And I think this is getting into 2C. You notice people are making a purchase or not making a purchase. The majority of people in this data set did what? To Emily or Alyssa right here. The majority of people in this data set either purchased or did not purchase. When you look at the data, the majority of the people in this data set did what? Did they purchase or not purchase? What did the majority of the people in the data set do? Did not purchase. That is going to come into use later right here. The smallest values for tenure are 0 or negative. We can't take the log of that. So if we try to transform it, we can't take the log. So we're going to do some stuff right here. Do I already put all this in? It's already done for you? I have the right one up, right? It's not one where work's already been done. Oh, good. So I think, unless I'm wrong, have we already added in? So the value, you need to add this, 3.6. So this is what this is going on right here, is this is taking the log. But let me point to the problem. Because some of these, if you were to not add on the associated values, we would see that we should get negative infinity right here. Yeah, we get negative infinity. Because some of these, hey Brian, will this cover the Stat 1 project? We did this, we can do some Stat 1 project, Dylan, if you want. We did a whole video on that yesterday. And so definitely we got a whole video. And we can do the mayor's positives, you bet. So we've got a whole video on that yesterday. And feel free to ask questions if you have it. We will jump in. We're doing a little 474. Then we're going to head over to a 201. We got this. So if you look at this right here, why are we doing this? The important thing to understand is why are we doing these transformations? So why are we going to add the value to this? And I've already transformed it, so let me reload. So if you look right here, this value of negative 774, what are we doing? We're adding this value to the data set. So what are we going to be making the lowest value in this data set? What will the lowest value in this data set now be if we add this to every single value in the data set? So if we were to take, it'd be positive, and then explicitly, what would it be? What would it be? It'd be 1. And so what is the log 10 of 1? What is the log 10 of 1? Log 10 of 1 is 0. So now via the transformation, by log 10ing it, which will bring in the large values, we're going to have data that's more normal, but also we can log 10 it because we have values that are all positive. You can't log 10 negative numbers. It just doesn't work. So that's why you get the negative infinities and you basically break. And we got NaN does not a number. That's what that means. So we have a bunch of stuff that just doesn't work here. It's because the data originally has negative 774. Why are we doing +1 right here to this data? Why are we doing +1? And then we're doing it to income, and age is fine, homeowners not quantitative, and area classification is not quantitative. Why are we doing +1 to savings balance? Why are we doing +1 to income? Why are we doing all those right there? Why are we doing that? And why tenure, I guess we're okay on. Let me see what it says on tenure really quick. Make sure I can read this screen too right here. So that's for all but tenure. Yeah, because tenure is not 0. You could add 0.7 to tenure. Don't do it. Don't do it. Don't do it. That's debatable because then if you log 10 it'd be 0. But one thing I want to point out right here is if you look at all of these, if you look at any of these, and it's not just positive. The biggest thing is you can't take the log 10 of 0. And you see here's the right skew distribution. This goes back to 201. It's a very, very right skew distribution. What will this review be over? Right now we're going over data mining. Yeah, feel free to ask any question you got, Sam. We got tons of time. So drop in a question and we'll do it. Any question you want. We're going over transformations and histograms right now. So we're talking about why are we changing this data? So what we're doing right here is we're doing a log 10 on these variables. And the whole point of doing these log 10s is to make the data look more what? So if I go back and I remake this histogram, the whole point is when I remake this histogram, which I haven't remade yet, the whole point of doing this transformation is to make the data look more what? This you'll see, Sam, how this applies to your class. More normal, exactly. So we remake the data right here and look at what we get. It's not perfectly normal, but it's a good bit more normal. At least it has a mound shape. It's unimodal now. And let's put some breaks in here. Let's go breaks equals and do 20. It's going to make it look crazy. Oh, it's breaks. I wrote break. It's still built up on that one side, but you can compare that to this one, which is very right skew. And so we get this one, which has a little bit more of a mound. I'll bring it over here so you can see it. This one has a little bit more of a mound compared to this one. Let's see how the transformations worked on the other ones. So the other variables, and drop any question you want in the chat. We got tons of time, and that's the best way to get a question in is to be like, hey, here's a question. Saving balance before the transformation. Ooh, that's really right skew. Look at that. That's as right skew can get. Then we apply the transformation to it. And what do we get? Yeah. It still has a buildup on the one side, but at least we have a mound shape. So after the transformation, we do achieve a little bit more normality, if not for all the zeros. Account income. So let's do that one. So let's go here to income. This is before the transformation. This one's going to probably turn out pretty well. And then let's transform it. And here's after the transformation, and you see it looks more normal. So here's the after the transformation. It's more unimodal symmetric. And here's before the transformation. It's more right skew. Interval question, kind of confused on part F on section 2 on the project. Is 40% from the value of the original question? Part 2, what we use for the null hypothesis. I think, let me look at that really, really quickly here, because we've covered this question. When we do all the transformations, or we'll run all the code above, then we'll run this chunk of data right here, and we achieve the values. So we're good. We understand what's going on right here. Let me double check the project. So let me get the project up and going right here. I just want to make sure. Here we go. 2F is it? So your supervisor thinks the true mean. Wait, is it 2F? So kind of confused. Part F on section 2. I'm on section 3. Here we go. Using your confidence interval, state the conclusion regarding the initial hypothesis in part A. Yep. That's it right there. Does that make sense, Abby? Great question, Abby. That is correct, that this is what you'll be using for your initial hypothesis in part A. And so great job. You're going to see if that value is in the interval. If it's in the interval, you will fail to reject it. If it's outside the interval, you will reject it. Does that make sense right there, Abby? Good question. It's not a relevant question at all. If you have any questions, if anyone's watching, put the question in here. We try to jump around, answer every question we can. And this is talking about how to use intervals to either reject a value or fail to reject a value. We might still have up. Sorry, everybody. I should get some water. We had that up yesterday. Oh, we drew it on the project. We drew it over here. So, yeah, let's do that. Let's do that one next. And then we'll come back and we'll do more on 474. If a value is inside this interval, so if this was my interval here and I was testing the value of 40%, I would fail to reject 40% because it's in the interval. If 40% was outside the interval, I would reject it. And I'd be rejecting this at the 0.008 alpha level. So an alpha level 0.008, I'd be rejecting it at. So kind of important to know what all these numbers mean right here. We've got here the X, the N. We've got here the probability, which is P hat. Did you ever chapter 15 quiz? You bet. Let's do a little 201, then we're going to come back to 474. So don't worry, 474. You know what I'm going to do? One more 474 because they were asking for B. And so we're going to split it into train and holdout. We've got some tips. Yesterday we looked at a test on the mean and jump for part F. For the null hypothesis is the T value of 0.05 or below a rejection or acceptance. And remember, we say reject or fail to reject, so always we do that. I did mine, but forgot which it is. So when the p-value is low, reject the null. So if the p-value is below 0.05, we reject the null. And then if the p-value is high, you just let it fly. You just let it be. So imagine this. Okay, let's look at it really quick. I think I still have jump data open. I didn't close everything down last night. Let's take this, and let's say I want to do something crazy real quick. So I'm going to answer Stan's question real quick. Let's say I said, do you think that UT students take on average 20 hours a semester? Just, I want you to tell me I reject that or don't reject that. Do you think on average that UT students take 20 hours a semester? What do you think about that claim? If I just told you that, I said, I think the average student takes about 20 hours. What would you do? Would you reject that or not reject that? I'd reject that. I'd say that's preposterous. That's ridiculous, Brian. Look at this interval right here. The interval goes from 14.87 to 15.52. So that's the 95% confidence interval for the true mean hours UT students are taking a semester. You can go right here to test mean, though. So we can go to the test the mean button. We can test the mean and put in 20. And guess what? 20 is way off the scale. So when you look at where 20 is at, so if we were to say our observed results of 15.2 are right here, and we're testing to see if 20 is true, which makes it the null value, it's at the center of the distribution, well, then we would reject it and say we would have evidence that there is a different amount of hours that students are taking. We could also reject and say less than. We can't reject and say we have evidence greater than. But when the p-value is low, you reject the null and you have evidence for the alternative. When the p-value is high, you just let it fly and you don't have evidence for the alternative. Does that make a little more sense, Sam, right here? With if we were to test 20 hours, we would reject that. Now, if I test 15 hours, would I reject 15 hours? Notice 15's in the interval. If 15 hours was tested, we would not reject 15 hours. So 15 hours as a null hypothesis would not be rejected. And you can once again see the red arrow. Move it over here. The red arrow or the red line is our observed result, and the p-value is high, telling us what we observed is very probable. It's very probable to see 15.2 hours given 15 is the truth. It's very unlikely to see 15.2 given 20 is the truth. So this assumes that this is the truth and you should see values around it. And here's what is likely to see. This would be very unlikely. Here's what is likely to see. And we kind of landed kind of close to the center of this curve, which is what we would expect if the null is true. So in this one, you reject the null and say you have evidence that it's different than 20 hours. This one, you fail to reject the null and say you don't have evidence that it's different from 15 hours. This one, the null is 20. I think I misspoke right there. So hopefully that makes more sense on nulls and alternatives and p-values. Reject the null, say you have evidence of a difference. Do not reject the null. You don't have evidence of a difference from 15. And we got some chapter 15 questions. Let's hop over. Keep putting those questions in the chat. Just rapid fire. Let me see right here. I need to log in to 201. 201. You know what? We need some punch-out music. We need some punch-out music while we're doing this right here. Almost got it. We've never been hit by Nintendo with a copyright over this. Thank you, Nintendo, for letting us use punch-out music. Getting my piercing to load. We need some Mega Man now. One more Mega Man and we got this. You gotta know which songs like don't get you copyright hit. Old school Nintendo music. Never thought I'd be saying old school when I was a kid. This is modern. This is Mega Man. Okay, let's hop over here. Let's do it. So this question right here, is this the one you were talking about, I think, Dan? This is the one Dan was looking at. And then we have Gigi's question next. So a mayor is concerned about his negatives, that is the percentage of residents who express disapproval in the job performance. So when we look at this right here, we should know instantaneously the null has the what sign. The null has the what sign. The null has the what sign. I need someone to put in the chat, like the null has this sign. Everyone should know that, like, boom. The null has this sign. It's always like the null has this sign. We just go, null has this sign. Null has the equal sign. So you could literally go through when you're working these questions and go through and put the equal sign for every single one of the nulls. The null has the equal sign. Now you have to look at the wording of the question to figure out which way the alternative goes. So we have right here, they want to keep their negatives below 73%. So they want to keep them below 73%. 73% would be the tested value, and they want to keep their negatives below. So what sign should we pick? Less than. Exactly. Nice job, Sam. Excellent work. Saying, is Mubot here in the chat? Mubot is here. Can I do points via this way? So you can talk to Mubot. I was going to say, Mubot, I'll tell you points and everything. And so is an 8-sided dice fair? So a dice is either going to be fair or not fair. So a dice is either going to be fair or not fair. Nice job right there, Dan. Dan, you're all the way at bronze tier. You'll get to silver tier before the end of the semester. So not equal to. Nice job, Sam, because the dice is fair or not fair. This last one right here, they're saying 19% of people who try to stop using drugs succeed. Sellers of a motivational tape say that listening to the recorded message can help people succeed. So they'd want to show evidence what? That the true proportion of people who succeed when using their motivational tapes is what? They'd want to say, we have evidence that the true proportion of people who succeed is greater than exactly. So you have to look at, this is the evidence-based claim, the alternative, and the null has the equal sign. It's just going to say, assuming this is true, what would we expect to see? They want to show evidence that it's greater than this. They're saying, I want to show evidence that it's not 19%, it's actually more than 19%. We're saying that it's increased because generally speaking, 19% of people succeed. We want to show a higher percent of people succeed with our motivational techniques. Your question is a multiple choice. Oh, let's find out. Is it the homework? Is it this one? Aha. This one right here. So this one right here looks like it might be it. This is a p-value question. So remember when we do a p-value, it's the probability of our results or results more extreme happening by random chance variation given that the null is true. So when we go and we look at this, this is it awesome. When we pull up our results from jump and we look at this p-value result, oh, we closed out the other one. Let's look at this one. So what are we assuming is the truth for this distribution? What are we assuming is the truth? Like, look at this distribution right here. And what are we assuming is the truth? I wish it made it more clear. We're assuming that 15.6 is the truth, and that's the center of the distribution. I don't know why it doesn't put 15.6 right at the center. I wish it did with the number line. Ah, there we go. So let's go to 14.5, 16.5, and then let's click OK. Oh, and then, well, that's why. And let's go to that. Sure. There we go. I feel the answer can't be too simple. Yeah, exactly. Because when we talk about this right here, here's our observed results. And if we're doing a less than test, we'd plot to the left. If we're doing a greater than test, we'd plot to the right. If we're doing the two-tailed test, we reflect it on both sides. So less than, two-tailed, and greater than. So if I do this result right here, this is where I landed. A p-value is always a what? A p-value is a what? Like, what does the p of p-value stand for? What does the p of p-value stand for? P-value is always this. It's going to be it's like the percent of time something would occur. It's telling us what an event is. It's going to be probability. It's going to be a probability. So it's going to be a probability. A p-value is a probability. It's telling us how likely an event was. And so it's saying our result of 15.2 or a result more extreme would only occur 0.0887 as a proportion of the time. Repeat, so it's a proportion, like the proportion of time it occurs, but a percent of time would be 0.887% of time. But this is the probability of this result or a result more extreme occurring by random chance variation, given that 15.6 is true. And if you listen to the interpretation there, it's, the probability of random variation producing a result as far as this, which is our observed result, given that the null is true. So what the null is for this is that there's no change in public opinion. I do a star. Oh, the star. I thought it said stand-up comedy question. Yeah, Chloe, we can do that. We'll do that here. I think Gigi has the one next. You got it. And then we're going to do some more 474. You got it. So 474, don't worry. Don't leave 474. So this is going to be the p-value interpretation. And Gigi had one in here. I didn't forget about you, Gigi. In 1980s, it was generally believed. Let's do that. Okay. In the 1980s, it was generally believed. So we're going to do 2 more 201. Oh, here we go. So in the 1980s, it was generally believed that congenital abnormalities affected about 7%. So it sounds a lot when you hear 7% is believed that that is going to be the what value. Be following along, right? To be practicing. With 7% generally believed, it sounds like that's going to be the what value. So if 7% is generally believed to be true, that is going to be the what value to start. If 7% is generally believed to be true, that is going to be, yes, exactly. Nice job right there, Gigi. That is going to be P naught, which is the null value. Exactly. That's P naught. And then we took a random sample of 374. That's going to be the sample size. From it, we observe this. That's going to be X. And they're saying right here that this is alpha. So that's their alpha of 0.05. So always identify your notation. Practice. N is the sample size. X is the number of successes in the sample. X over N equals P hat. So we should go X over N equals P hat. And P hat is going to be equal to 33 over 374. And there it is right there, 0.08823. There we go, that's P hat. And now we just have to solve the equation. Well, I guess they're asking, let's look, is there strong evidence that this has increased? So what is the sign for the alternative? So one thing we can do is we can start writing out our null in basic format. What is 5%? It's going to be alpha. Alpha is the point at which we reject. So when p-values are lower than alpha, alpha is like your rejection point. Imagine I have a scale down here, and I say, okay, anytime my p-value is less than alpha, with alpha like 0.05, if a p-value is less than this, this would be my rejection zone, and this would be my not rejection zone. So your alpha is the point at which you reject. It just, people say this is like when we reject the null. And usually alpha is 0.05. Unless otherwise stated, you assume alpha 0.05. So if my p-value were to be something like, let's say I had a p-value of 0.02, would I reject the null here? If I have a p-value of 0.02, would I reject the null? Would this reject the null here? Is my p-value less than alpha? Would I say I reject the null? Yes. But here's where interesting things can happen, is if you were to then change alpha, which you can do, and you were to say alpha is now this, and I were to say I have a p-value of something like this right here, would I reject the null now? With a p-value, with an alpha of 0.10 and a p-value of 0.08, would I reject the null? So I'm asking in a tricky way. I should be like, would we reject the null? And you'd still reject it. And so hopefully the color coding helps too. No one's red, green, colorblind, I hope. But if you were to change this and you were to change what your alpha is, and you were to maybe say alpha were to again equal 0.05, and I'm not moving the bar visually, I'm just going to redraw it like this, then you would have landed over here. That is where your p-value would land, and you would not reject the null. So the alpha is just kind of your measurement. Is it, at or, no, it'd be below alpha. You technically, so it's just below alpha technically, because we always say reject below 0.05. 0.05 is still not reject. Hopefully you don't see 0.05, and there's ways to deal with that with advanced statistics, but below alpha, when p-value is below alpha, reject the null. When the p-value is lower than alpha, reject the null. Great job right there, Sam. And so we're going to write out the basic format, and that's exactly what it is. It's the rejection point. Excellent work. P equals P naught. Alternative, P greater than P naught. And we've already know what P naught is. We identified P naught to be 7%. And here is 7%. From here, let's go ahead and solve the equation because we have everything we need. Nice job, Gigi. Excellent work. We're going to go here and do P hat minus P naught over P naught. Who knows what Q naught is? Because we don't have Q naught listed. Does anyone know what Q naught is? Does anyone know? I didn't even realize that. I didn't even see that error, GG. There was no error. I didn't see anything. Does anyone know what Q naught is? Because we don't have Q naught listed. Close. Q naught is going to be very, very close right there. Yep. It's going to be 1 minus P naught. So Q naught and P naught are complements. So Q naught and P naught add up. Yeah, no. I figured you got it. It's so easy. I'll make mistakes. Just wait for me. I think people don't realize it. Like, no one remembers mistakes other people make. You really only remember the mistakes you make. You're like, oh, that one time I gave a wrong answer, and everyone's like, what are you talking about? You always give right answers. And you're like, but that one time. And so there's this, and then we'll solve for z. Let's solve for z. 0.07 times 0.93, 374. Oh, 17406. 17406. Oof. That's gotta be off. What did I do? Oh, did I not square root it? I don't think I square rooted it. Yeah, I didn't square root it. That's why. That's when you get a number that big, you're like, something went weird. There we go. 1.3817. Where are we going to go? Everyone knows where we're going to go right now. Everyone should know. 1.3817. You should know once we get a z-score, we're going to our best friend in the whole wide world, This guy just wanted us to say his name every day for the rest of the semester. We're going to Mr. David M. Lane. So everybody knows where we go when we get a Z-score. We go over to Mr. David M. Lane, and we drop in the chat right there so people can know, 1.38. So this is the greater than... What's the p-value going to be? About 0.086, I say. 0.086. I say 0.086. 0.084. 0.084. So let's go ahead, and I think we've solved most of the question. Let's go look at the question real quick. And so first we needed the null and the alternative. The null has the equal sign. Hey, what's up, Alan? So good to see you here. So, Alan, missed you. What's happening? Oh, wait, class later day, right? I'll be seeing you soon. The conditions are we need at least 10 successes, at least 10 failures, random and independent, and less than 10%. The p-value, it jumps right to the p-value. This is probably the tricky part. So I think we figured out that. And the p-value is the probability of observing what we saw or more extreme due to random chance variation given that the null is true. This talks about given that the null is true, and it's the probability of our result, which is this right here. What is your conclusion? And we're using a 5%. Will we reject or not reject the null? Will we reject or not reject the null? Because our p-value is this, and the alpha level is this. Will we reject or not reject the null? Which of those will we do? Reject or not reject? P-value is high. Oh, thank you, Alan. That's awesome. Positivity. We will not reject the null. Exactly. We will fail to reject. There is not evidence. When you reject, there is evidence. When you fail to reject, there's not evidence for the alternative. The alternative requires evidence, so we reject. There is evidence. We fail to reject. There's not evidence. And we fail to reject because the p-value is high. It is unknown if environmental things would do it. This test does not talk about causation, so we can't say there's causation. I think we got everything. We got it. Get a little bit worried when I hit that button. Like, oh no, something's going to go wrong. And then I think there was one more that we're going to jump back over to 474. Startup company question. Let's look for the startup one. Let's find the startup. Where is the startup? Oh, there it is. I was about to go past it. So here's the startup company question. And let's take a look. So we fail to reject because there's no evidence. There is no evidence because we fail to reject. Yeah, kind of, sort of. Whenever you fail to reject the null, there's not evidence for the alternative. If there was evidence for the alternative, what would you do to the null? Like if you're like, I have evidence for the alternative. I've got evidence that indicates to me the alternative is true. If you had evidence for the alternative, you would what the null? Because if you're going to believe the alternative, then you have to reject the null. Does that make sense? If you say I have evidence for the alternative, you're like, well, then I'm going to throw away the null. Because rejecting it basically means I'm doing away with it. I'm not going to use the null anymore. Let's hop here. Let's drop the question. We'll go one font bigger on the question. We need more Word documents open. Let's see how many Word documents this computer can handle. I should put like a quick key to open a new Word document. We'll just go all this week. No closing of Word. So here we are. A startup company is trying to market a new printer. It decides to gamble by running commercials during a championships game. The company hopes the name recognition will be worth the high cost of the ads. The goal of the company is to get over 39%. Okay, wait a minute. We just got two things instantaneously. What two things do you notice right here? Over and 39%. We just got two things instantaneously. So of the public recognizing its name brand and associated with the computer equipment the day after the game, a pollster talks to this many people, and this many say they have a name brand recognition. Would the company, or would you recommend that the company continue to advertise on these things? So we've got everything identified in this problem now. What notation is there? And then right here we have an alpha of 0.05 again, which is our rejection point. Any one of these. Who knows any one of these? Yep, this is P naught right here because that's our null. And this is going to be X. This is going to be N. And this right here is going to be the greater than for the alternative. Nice job right there, Gigi. Excellent work. It's when you practice, it's just, you got to do a bunch of these problems. The more you practice them, the more you can identify the notation. Then we simply go into just solving through everything. We just solve through it. We take all the notation we have and we say, okay, let's go here. Let's write our general form using the proportion where we go P equals P naught. The null has the equal sign. P greater than P naught. Let's replace P naught with its value. P naught is 0.39. And I want to once again illustrate the only thing that changes between the null and the alternative is the sign. The only thing that changes between the null and alternative is the sign. That's the only thing that changes. You just change the sign, boom, you got your alternative. Less than, greater than, or not equal to, depending on the wording of the question. So now we go and we find Q naught. Q naught is equal to 0.61. Q naught and P naughts are complements of each other, so these two should add up to 1. Make sure you do that. Now we go and we go 0. Let me write out the equation first. Whoa, there we go. So P hat minus P naught over P naught Q naught over N square root equals to a z-score, just right on the edge of that. And we don't know what P hat is so far. P hat equals 2x over N. So let's go solve that. 186 divided by 404. There it is right there, 46.03. And then we're going to do some 474 right after this. I have not forgotten about you, 474. I have not forgotten. And so now we need to take 0.4603 and subtract 39. That's going to be a big difference. P naught. Do you always solve for P hat? Yep. It can be given to you. Good question right there, Sam. It can be given to you in the problem. The problem can say this is the sample proportion. So a problem can state the sample proportion. It just depends on how the problem's worded. Some of them give you the answer, and some of them don't. And so it depends. We're gonna lose that. But no, good question. The problem would just say something like, in a sample they found this, and then that would be P hat. So this problem could have read, in a sample of 404 they found 46.03%. So it could just give P hat by stating it. And sometimes they do that. That's kind of mixing up the problem the way it's worded. There is the z-score. Okay, I know we can do this without the help of, I think that's what it rounds to 2 decimals. Usually they say 2. Nope, rounds up. We can do this without using David M. Lane. So we're going to get this z-score entered in. Let's go look at the problem now. We've got right here, it's got to have the equal sign, and we're doing greater than because we're trying to see if there's more name recognition. So the test statistic right here was 2.90. And we're gonna take a big jump at this. You ready? The p-value to 3 decimals. Does anyone have any guess what this p-value will be to 3 decimals? I think I know what it'll be. I think I can get it. The p-value to 3 decimals, I'm saying that. I think that'll be it. I'm wondering if it's 0.003. I think that's what the p-value will be to 3 decimals. We'll find out here in a second. Would you recommend... So think about this. What are you doing to the null right here? If this is the p-value, which I think it is, if this is the p-value, what will you do to the null hypothesis that they are getting 39% name recognition? You will what the null with this p-value right here. With this p-value, you will what the null. So what will you do to the null hypothesis with this p-value? You will do what to the null? So the p-value is very low. You'll reject the null. That means you have evidence that the name recognition is greater than 39%. So that means, yeah, we should. So since the null hypothesis is rejected, there is evidence that more than 39% of the public recognizes the brand. So yes, since it is rejected, did we do it? We got it. And that's how you guess the p-value. The p-value there was the z-score was so extreme that above it, there's basically, like, yeah, that was very close right there. Because we should know at 3 is 0.0015, very close to that, 0.0013, I think. There we go. And that's above 3, like, if you know all the decimals and work it out. But I basically used this to say, well, this is virtually identical. It's just a tiny bit over. So with my knowledge of what this number was right here, I knew it was that. Then I went ahead and just went, okay, it's the tiniest bit more. So kind of taking these guesses right here can help you and help better understand how the curve works. And exactly, Dan, because the p-value, because 0.05 is greater than that, or I would say because 0.002 is less than 0.05. So excellent work, Dan and Sam. Great job. It's practice makes perfect with these. Practice makes perfect. We're going to do a little more coding here. So let's hop back into the coding. I lost my chat. Okay. So right here with Q2B for 474. You're welcome, Gigi. Great job right there. Excellent work. Practice, practice, practice. We're going to make our training rows right here. Was the z-score positive because it was greater than? Yes, exactly. If the z-score was 0, Chloe, and glad to have you here, Chloe. If the z-score was 0, it would be exactly on the null. If the z-score is negative, it's below the null. And if the z-score is positive, it's above the null. So because we viewed more, then the z-score was positive. And be careful, though. Don't always reject because the z-score is positive. Because what if our z-score was something like this? Would you reject the null with a z-score? If our z-score was this, would you reject the null here? Now, we did land above 39%, which is at the null. So would you reject right here if this was your z-score? We are above 39%. Maybe this was like 39.8%. In this instance, we would not reject the null. When do we reject the null? When this p-value here is below 0.05. So we reject the null when the p-value is smaller than alpha. So if this was your p-value, you would not reject the null, even though you landed above 39%. 39% here would be right at the center, and if you landed on 39%, you'd get a p-value of 0.50, and you definitely not reject the null. Is that making sense, Chloe? Does that kind of all work right there? Make Chloe a mod. We just have a whole mod team on her. I think we had someone else who wasn't a mod yet. Abby, let's make Abby a mod. And I think, did we answer? We answered Abby's question too. Good stuff right there. And so, awesome, Sam and everybody. Great stuff. This is, we're going to divide our data. So people are wondering, what are we doing? We're going to divide our data into two parts right here. So we need to divide, I sent you a song. Yes, will do. Thank you so much. I appreciate that. We go 1 through the number of rows. What this does right here is this just samples the rows. So this is a random sample of the rows. These are all the rows that we have in this data set. And we want to take 70%. So 70% of these rows right here will be taken. And it's a count data set. There we go. And there's the 70% right there. And then we need to divide up into the train rows. So we do train rows here. And then we do minus train rows here. And I was like, what is it mad about? And there's our training and holdout data. So we've created our training and holdout. Nice job, Chloe. So we've got our training and holdout data. I don't know if there's a sanity check, but we should be good. Now we have to define the fit control. The fit control, as a reminder, is how we decide which model we're going to pick. It's going to be the internal validation, the validation portion of our data. So let's look right here. We've got the method, and I think, does it say which one to use? Okay. So it looks like it's going to be using, let's see, 5-fold cross-validation, and the AUC will be computed. So for the method right here, we need to do CV. For the number of folds, we need to do 5. Class probs equals true, and summary function equals true. We were going over this today right here. Let's go to class probs. Here we are. And if you notice, this is basically what we're doing right here. So you can double check your code if you want and go back. And this is for a categorical prediction, and it's just spaced out a little bit differently. I'm looking here. I feel like something's different. Summary function. Oh, I made a mistake. There we go. And something else seems different. Oh, wait. Summary function equals to class summary. Class props equals true. I think it just has spaces. Number. There we go. Make sure everything is identical. And I think that's got it. There we go. Summary function equals to class summary. This makes sure it's binomial. And class probs equals true because we're doing categorical stuff. So we have everything we need right here, and we store it like that. So this thing right here is a huge, big help. This is the file that we were going over this morning, and we went through in-depth talking about this. So check out the video if you want. But we paused on this, and we went through all the different types of validation that we're using, and that is what we're using right here in this file. This was the one we did in class today. So we coded all this in class and got that working. What class would the naive model predict for everybody? What is the naive model's accuracy on the training data and on the holdout sample? So when we use the naive model is just going to go, and let's do a summary of the account data, training data, excuse me. And here's the answer. So I'm not going to quite say the data or say the answer, but I'm going to kind of allude to it. The naive model uses the majority level for the data. So think about this. So 201, you ready to learn about the naive model? So if someone's in 201, see if you can answer this. If most students or most people you see on campus go to the University of Tennessee, what would you assume if you saw a random person? Let's say most, like when you're walking around campus, most people you see, like 80% of people go to the University of Tennessee. So if you see a random person, what would you assume about a random person on campus? Like just not like a random person, but any person you see on campus, what should you assume if you just see someone on campus? Which is kind of a funny story. Which is, oh man, I'm gonna tell a quick story here. I can't believe they said this. So I was down by the clock tower in Humanities Courtyard or whatever, like where the library is. And so I was kind of like debating this guy, and he and I like later became friends and we talk a lot. But I was debating him on a topic, and I like conversations with people. I miss the world. But he and I were debating a topic, and this guy walks up to us and he goes, "I need to see both of your IDs. I work here." And I was like, "Oh, I work here too." And he's like, "Do you?" And I was like, "Yeah." And he's like, "I need to see your ID too." And I was like, "Okay, guys. I mean, like, I don't think I need an ID to be on campus, but I wonder who that was. Who said that to me. But I wasn't doing anything. We were just like debating a topic, and we weren't like getting loud or anything. We were just like discussing it, and I don't know why he was sure. But that's too crazy. So what would you assume if you saw someone on campus? What would you assume if you saw like random person? You would assume that they're a student or that they work at UT or they're some part of UT, part of our UT community. So that's kind of the default, and that's the naive model without any indication otherwise. I guess he saw me debating someone. He's like, that guy's debating someone. He's not gonna be the UT student. I don't know. It's fun to debate people. It's fun to have discussions and hash out ideas. But with this, the naive model, what would the naive model predict for this data? What would the naive model predict for this data? Any ideas? What would the naive model predict? I don't know if a 474 person's here. But think about the example if you're listening to this 474, where most people on campus are like affiliated with UT. So if you saw a random person, just like you look over, you see someone, you're like, oh, they're probably affiliated with UT. So when you look at this data right here, what would you assume about this data? And we can see how it does on the holdout by going right here and just changing this to the holdout data. And we can see, okay, wait a minute, this predicts this well on the holdout, and what percent of the time would it be correct? So I'm going to let 474 kind of think over this a little bit here. I don't want to give away the full answers. My no and yes are different numbers. Let me see right here, because if people are using, let me run the set seed on this to make sure. Maybe I didn't run set seed. Are you getting these numbers right here? Oh, let's see, because I don't think I ran set seed. Sorry about that. Are these numbers you're getting, Emily? These are probably the numbers you're getting now. Sorry, I didn't run set seed. Emily, 1,000 points. Hopefully these are the numbers you're getting, because I ran set seed now. I'll check one other thing if they're different. And I'm going to try to, if the graders take off points, please tell me, because everyone should be getting same numbers, and it's just the fun of seeds. How does this look? They're still different? Let me try this. So let's go here to RNG kind. Is it sample kind? There we go. And that's what we got just a moment ago. Is that what you're getting, Emily? So, and double check, I think we're supposed to be using rejection. There's a rejection or rounding for the RNG kind. It's like how you set your randomness. That's what you're getting? Okay, cool. So maybe we are using rounding. I think I set rounding at the start of this document. Wait. Did this get updated again? Oh, this got updated again. You might have because we put out so many updates. Well, that's going to be interesting. Because it got updated again. And so because of the update... might have to... This is due... Is this due tonight? So many due dates on assignments floating around in my head. Let me see. So we updated it. And it is due in 2 days. Okay, so we'll definitely... I'll probably be sending an announcement here. I was also thinking different numbers for 1D and 1E, but I wasn't sure if I just had the wrong code. Because this update happened right here, because I made some changes... Oh, wait, I'm in the solutions? No wonder the answer was there. I just should have... Wait, maybe we named this solutions. My brain's broken. I'm having trouble finding Z statistics on the quiz. I follow the formula, but I keep always getting a number way too high. We'll look at 1D and 1E. Which one are you working on, Alex? Put the problem you're working on, and then we'll work on that one. We'll follow through the steps. We'll make sure it works. You got it, Alex. Let's do that. 1D and 1E. The numbers right here... When you, if you want, Emily, send me your code via Discord. I have 10 plus messages on Discord and 9 plus messages on Discord right now. Send me your code on Discord and I'll double check it because I think we've updated this file again. So if you're not getting certain sanity checks, let me know. And Discord is awesome. You got a 100. Nice job, Dan. Excellent work. Love hearing that, Dan. And so, Emily, if you want to send me your file, I can take a look at it there and I can reply a little bit later today. We got tons of time. As long as your code is doing the right thing, you should be good. But let me know. Send me the thing, and I will take a look. And does that make sense, Emily? Because I think because we updated the file, and I might send out an announcement saying, like, the file's been updated. Just put your code in the new file. You know, like, make sure, you know, that it has the syntax. You can email it to me, too. You can email it to me if you want. Discord works really well to just, like, quickly send stuff. But emailing's perfectly fine, too. And I like Discord too because I can kind of see like, okay, I've got these 8 messages and then it's just a constant conversation between. Also, what is the proper way to put the equation in the calculator? Which calculator? You're talking about this one right here? And we'll see for the Z-score. X is recovered and delivered to its owner within 24 past hours. Consumer group with a large number of travelers. Find only X and X people who lost luggage. Yeah, let's go next. I should do a quick, Alan, that'd be amazing. Alan, that would be great. And thank you, Alan, for server boosting us all the time. We really appreciate that. It's a big help because then we get the faster rates and the better voice calls. And I want to always keep growing the Discord. Next semester, go to more. X is recovered. Is this the one right here? This is the one right here, right? Thank you, Alan. Yeah, this is the one. Awesome. Okay. So the assumptions for this model right here are random. We haven't pressed the random button today. We got to press the random button. So we have here random 10% and success failure, which is our first document from yesterday. Random 10% and success failure. Here we are right here. Random 10% and success failure are the conditions. Why is it success failure? Because it's categorical data. So with categorical data, if we're doing a confidence interval or a test, I think we're doing a test here. So with a test, we are going to use NP0 greater than or equal to 10 and NQ0 greater than or equal to 10. It means we need at least 10 expected successes, at least 10 expected failures. We do meet these conditions because we would expect with 9% of these 151, we'd expect 14 of them, and 91% of these 151 travelers, we'd expect 137. So we'd expect at least 10 to not get their luggage. Yeah, I think check. You might have hit M on keyboard. Double check. Are you back? Are you back, Alex? If you hit M, it mutes it. So I've done that by accident. I've been like typing or something and like went over to YouTube and hit M. Spacebar on YouTube pauses videos. That's super helpful. I'm telling all the hacker tricks right here. Someone turned on this outside speakers. What am I being broadcast to right now? What am I being broadcast? What do you see right here, Alex? The null always has the what sign. The null always has the what sign. What sign does the null always have? The null always has this sign. Well, it's in this question, so it's pretty obvious. The null always has the equal sign. So when you think about this, the consumer agency is trying to show that, nice job, Alex, right there. The consumer agency is trying to show that they are not meeting their goals. So would they do greater than, not equal to, or less than? Which of these would the consumer agency try to show? Would they say that they have greater than the proportion being returned to the customers, not equal to the proportion, or less than the proportion being not returned to the customers? So these are the, like, are they meeting this goal of 91%? Are they not meeting this goal? Are they making less than this goal? What would a consumer protection agency try to show for an airline? What would they try to show? They would try to show that they're getting less than that goal. Now, the important thing we should know is that when we choose this, it'll determine which way we shade the curve. When we do our test right here, probably going to get something less than. So we're going to get a negative number, and we're going to shade lower than it. Nice job, Alex, right there. I made you mod on the channel, too. And so we're going to shade to the left, and that's what the alternative tells us. The alternative tells us which way to shade the curve. The alternative tells us which way to shade it. Determine the z statistic. Okay, so let's go ahead and take the question right here. And when we take the question, jump to a new data sheet, paste in the question, and we see right here that we have 91% is the null value. So this is going to be P naught. This is 85 out of 151. And I think that's got it. I think it's all of our numbers. So now we need Q naught. Q naught is 1 minus P naught. And so now we do P hat minus P naught over P naught Q naught. Sometimes people put P hat in the bottom, so that's where a mistake can happen. Equals our z-score. X over n equals P hat. And so 85 over 151. And there it is right there, 0.5629. See it? Is P hat? Yes, great job right there. Yep. P hat is 85 over 151. Perfect practice. The number of successes over the number of trials. And then last but not least, let's start plugging in our Oh, I forgot a square root on that. There we go. So I was like, something doesn't look right. And so now we go in and put in 151 and 0.5629 and 0.91. Wow, we're going to get a crazy z-score right here. This z-score is going to be absurd because they're way below what they thought. What is that 44 doing there? Oh, I think because I hit it on my mouse, right? Yep. Your mouse has buttons. And so now let's go right here and do this value. Oh, always do the bottom first. Divided by 151, square root, 0.5629 minus 0.91, divided by this. There we go, 14.90, negative 14.90. And that is the z-score. Now, what should the p-value be with this large of a z-score? What is the p-value going to be with this large of a z-score? This z-score is insane. This z-score is absurd. It's way off the charts. We can go and plot it, but it's so off the chart, I can tell you that the p-value is going to be 0. It's off the charts. You can't even see it. It's way off the scale. So basically what we observed is basically impossible given the claim is true. So what we observed has a p-value of 0 telling us that what we observed was basically impossible. Should we reject the null? Most definitely. So it casts doubt, yes, since the null hypothesis is rejected. Wait. Am I going mad? This is the same answer. What the heck? Anyone else going mad right here? Yes, since the null hypothesis is rejected. Yes, since the null hypothesis is rejected. Is not rejected. Same thing. Wow, I don't know. Alternative universe I'm in right now. I don't know. So yes, since the null hypothesis is rejected, it's going to shed doubt on their claim. 100. Love seeing hundreds right there. Does this make more sense, Alex? Did you get it? You said you were working on the z-score. So if you remember, I have the same options. That's so weird, isn't it? That's so weird. What's going on, man? So hopefully this notation here helps with this problem. But we've gotten all the notation. Carry all your decimals, and yeah, the z-score is basically impossible. Well, basically, when we say basically impossible in statistics, we're saying that it has a p-value basically close to 0. Yeah, it's basically impossible. Great job, Alex. I hope this makes a lot more sense right here and that you got the answer, but I think you got it. Did you get 100 on it? We'll find out. We'll see if anyone else has some questions. Really good office hours today. Got a lot done. A lot of new people here today. Love it. We'll be doing a lot of review for the final. I'll probably be like streaming during... we're going to have a long stream tomorrow. We'll do project stuff, but I have the big project video. So check out the big project video from yesterday. We walked through the whole project. I'll probably be answering questions tomorrow on the project. I mean, I'm always here to answer questions on everything. I just try to like divvy up my time between all the classes. I'm like, wait, 474, 320, 201, hit my elbow against the desk. But I think that's got it. Any other last questions? We should end with a fun video today. We should end the fun video. Don't know if Alan's still here. I think it's time. Time to say goodbye. Gracias. Es muy bueno. You're here, Alan. Muchos años pasado yo trabajé en un restaurante. Muchos años pasado. Ay, 18 años. Yo fui 21 cuando yo trabajé en un restaurante. I missed that. I think it's got it. We will end here. Let's end with everything is fine. Great Spanish? I hope. I lost a lot of my words. I miss speaking Spanish in the restaurant. So, yo espero hablar con muchas personas que hablan español. No, I don't know how to say opportunities and stuff. I just don't have opportunities where, I mean, I guess I can't go out and speak to random people and be like, hey, you look, don't say that to people. You look like you speak. No, I just don't, when I worked in the restaurant, I had a lot of opportunities to speak Spanish, and then I would try to like not speak English, and that was the real fun. Yeah, if you forgot all your Korean, no. The more you use it, that's the whole thing. You have to use it. If you use it, you remember it. And I don't use my Spanish. I haven't had a real conversation in Spanish in years. And so back when I was in the restaurant and every day I'd come in and try to talk Spanish every day, I think they would laugh at me sometimes. I mean, this is having fun. But then after a while, it got to be like, oh, he can speak a little Spanish. Like he can talk. None of my Korean friends stayed home, and I haven't seen them. Oh no! I just dropped Spanish 111 rip. Oh no! But don't worry, Alex. That's perfectly fine. We're there for you, Alex. We're there for you. It's a whole different world right now we live in with online teaching. None of your Korean friends came to campus. Oh man. Hop online, hop on Discord, talk to them on Discord. I know so little Korean. You know, Alan, how I know any Korean is from K-pop. We know so little Korean. We'll hear a word and we'll be like, wait, that's that word we hear in every song. It's from K-pop. I know any words in a Blackpink song. That's what I know. I only know words that are sung in Blackpink song. So I know say "Kill This Love." What is it? The new song. What is the new Ice Cream? Is it something like that? Yena had a song, Ice Cream. Everyone just makes ice cream songs. I know how to introduce myself. Everyone knows I like Block B more than I like BTS though. Everyone needs to know them. I mean, or 17. Well, that's a guy group right there because there's 17 guys in it. So Red Velvet. We're just gonna end talking about every K-pop group there is. Stray Kids, yeah. Did you send me? Yeah, Stray Kids. They're the ones who sing Face, right? They sing Face, right? That is my favorite song by them. If I'm thinking of Stray Kids correctly, they sing Face. That is my jam right there. Go look that up. Stray Kids Face. That is the best song. It's like high school drama song. Like, I don't know. People trying to fight them because they're outsiders. My favorite is EX. The song EX, I'm trying to think if I know the song EX. I'm trying to think if I know. You're not talking about the, because there's EX. There's a group EXO. I'll have to look at EX. I've probably heard it. I'm still confused what don't reject a null hypothesis means. So what don't, so good question. We'll hop back on topic here. When we don't reject the null, that's the same thing as, so imagine this. I tell you, Alex, that I can run a 6-minute mile, and you say, no, I think you're way slower than that. And then you go out and I run a mile and you see me run it in 6 minutes. Like we go to a real track, you see me run it in 6 minutes. What would you do to the hypothesis that I can run a 6-minute mile? So think about this. I tell you I can run a 6-minute mile, and then I go out and run it. What would you say? What would you do to the null of me running a 6-minute mile? What would you do? Would you reject it or not reject it? So I say, I can run a 6-minute mile. You say, I think you're slower than that, Brian. Yeah, you would lose the bet. You're right. So the null is Brian is a 6-minute mile runner. So the null is that Brian's mile time, my average mile time is equal to 6 minutes. The alternative would be my average mile time is greater than 6 minutes. So if you went out and saw me run a 6-minute mile, you would do what? You would reject the null or not reject the null. You see me run a 6-minute mile. So if you saw me run a 6-minute mile, you'd say like, oh, I'm going to what the null now? Reject it or not reject it? If you saw me run a 6-minute mile, you're like, Brian claims he's a 6-minute mile runner. You would reject it, but you just saw me do it. You just saw me do it. I claim I can run a 6-minute mile, and then you just saw me run a 6-minute mile. So I claim I can run a 6-minute mile, and then you go out and see me run a 6-minute mile. You would fail to reject it. You'd be like, well, Brian said he could do it, and what I observed was in line with this. But what if, it's going to keep doing that, what if you went out and you watched me run a mile and it took me 10 minutes? Then what would you do? So you don't accept it as true, you just don't have evidence to go against it. So, because it could be that I'm a 6:02 mile runner or a 6, because think about this. What if I tell you I can run a 6-minute mile and then you watch me run it in 6:01? Would you reject the null if you saw me run a mile in 6:01? So I tell you I can run a 6-minute mile and then you see me run it in 6:01. Would you reject the null then? You'd be like, Brian, you're 1 second slower. I saw it. I reject the null. I have evidence that your time is greater. You'd probably say, no, I can't reject the null. That's not enough evidence. What if you saw me run it in 6:20? What about 6:40? At 7, at 7:20, at 7:40, at 8 minutes? At some point, I'd be far enough away, and that's what the distribution does. At some point, I'd be far enough away from the center of it that the p-value would get very, very what? If you go further and further out, the p-value is going to keep getting water every time you go further out. The further out I go, the p-value is going to keep getting water. The p-value is going to keep getting water the further I go from 6-minute mile. Because 6-minute miles here at the center, it's going to get smaller. Meaning that my claim is what likely to be true the further away I am. Meaning since the p-value is getting smaller, the probability of observing what you did, given the claim is true, is getting what likely? As you say, it's smaller, it's less likely. Does that make sense? So if you see me run something, and these are kind of fake times right here, like maybe this is 6.5 minute mile runner, 7-minute mile runner, 7.5 or 8, maybe at some point this is enough evidence for you to reject the null. If you saw me run it in 6.5 minutes, that might not be enough evidence. You might say, well, Brian ran it in 6:30. I guess it's believable he can run miles in 6 minutes. He's not like his average mile time is 6 minutes. I guess that's possible. Like I don't have enough evidence to reject that. So you're not saying you believe the null is true. You're just saying you don't have enough evidence to go against it. Generally, so with z-scores, and this only applies to z-scores, the point of rejection for z-scores are going to be, here we'll do a new page. On z-scores, on a one-tailed test for z-scores, the rejection point for one-tailed tests is going to be 1.645. So this would be 1.645, and that's the greater than test rejection point. And the less than test rejection point is the other side, which is negative 1.645. And outside of these is 5% of the curve. So here's 5%, and here's 5%. Now on the two-tailed test, it's the classic 1.96. And this only applies to z-scores, not t-scores. And this is for the does not equals test. The does not equals test has the area on both sides. So if you're doing a greater than test and you get a z-score of greater than 1.645, you will reject the null. But these are the rejection regions with alpha equal to 0.05. So it does depend on alpha too, but this is kind of classic stuff right here. But those are the z-scores which you would get values more extreme than a reject, depending on your type of test. Greater than test, 1.645, less than test, negative 1.645, and does not equals test 1.96. And you can confirm these by going to David M. Lane and trying the values and going here to above 1.645, and you will get that. And below, it's just going to be the same thing. And there's where you would have p-values smaller than 5%. And then outside of 1.96. So this is what I was drawing right here as I was drawing these shadings on the curve right here. So these are just classic z-scores that are used a lot. But I think it's got it. Does this make a little bit more sense, Alex, that the further we are away from the null, the more evidence we have against the null? We never believe the null is true. It's just we either continue to believe the null, as in we have nothing to go against it. So I guess this is true. It's not saying this is true, but sure, Brian ran his miles in 6:20. It's not enough evidence to say that he takes longer than 6 minutes. It's possible that he's a 6-minute mile runner. This is just variation around it. Because maybe when Brian ran his mile in 6:20, his z-score was this. Brian took longer than 6 minutes, but it's possible that maybe just natural variation in Brian's running had him run this time. So it's possible that Brian is still a 6-minute mile runner. So we're not going to say I have enough evidence to go against this. But if Brian is taking 7 minutes, we'll probably get something closer to this. And then we'll be like, oh, wow. Yeah, that's some strong evidence that Brian's not a 6-minute mile runner. This is unlikely to occur if Brian is a 6-minute mile runner. Thus, I reject that Brian is a 6-minute mile runner. So either reject the null or don't reject the null. We never accept the null. We just say, because science is always learning. Science is always testing. So science will either say, I continue to believe this, or I no longer believe this. Does it make a little bit more sense, Alex? I hope. Feel free to ask any questions you have. I'm going to head off here in just 1 second. We got our K-pop talk in for the day. I think that's got it. Twice is great. I think I haven't heard too much. Yeah, we never say accept the null. You just say reject or do not reject. And do not reject is same as fail to reject. I like twice. I like the early stuff. That's what everyone would say, right? Like TT and I can't think of the other ones. The one with the zombie. That was their first one. Can't think. Ooh, ah, ooh, ah, yeah. I was singing. Ooh, da 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 da. Ooh, ah, ooh. Da, da, da. Yeah, that's a good one. And then what's the knock knock? Knock knock's the other one. The Christmas one's knock knock. I really like knock knock. They have a lot of fun, playful songs. Knock knock, ooh, TT. A lot of alliteration in there. Cheer up, yeah. Cheer up, baby. Yeah, I'm gonna not sing any more K-pop songs. Yeah, Cheer Up's great too. I forgot about Cheer Up. Yeah, Twice is really good. Twice was one of Chelsea's favorites for quite a while, and then Blackpink came out and just destroyed everything. Because I think Twice was out like a year before Blackpink. So Twice was the big thing, and then Blackpink in your house. Just craziness. We watched the Blackpink documentary, and that was awesome. So it was really good stuff. It's really interesting, like hearing about their lives, and because some of them are from like Australia. Yeah, YG and JYP always in competition. Yeah. I can't remember which one. We saw like the introduction thing where they introduced Blackpink and everything. They came out, and you can tell how much they've changed and grown since then, because the personalities are a lot more. I think you get a little bit of confidence when you've become this big. But even then, they still go on stage sometimes, and it seems they still have, like, am I gonna sing this one correctly? Is the dance number gonna work properly? And they are talented. Which one is it? Is it Rosie? Maybe I'm getting her name wrong. She's really great with instruments, like really great, talented when it comes to music. Like she plays guitar and piano and everything. Well, next question: what's the formula for finding the z-statistics in one equation I can plug into a calculator? So the equation for the z-statistic for the test that we were doing is 1 prop z test, and it is p hat minus p naught over p naught q naught over n Oh gosh. Square root. There it is right there. And I've got a video on this. I've got a video on how to do it on the TI calculator. Let me go find that real quick. YouTube stat21 UTK. No, wrong playlist. Oh man. 4 people watching. TI tutorials. There we go, TI tutorials. Let me send you the one prop Z test. There we go. Here's the one prop Z test. And this is how to do it on the TI calculator right there, one of my videos. And I think that's got it. Alan, good talking to you. I'll be checking out the video. I'll be teaching you in a little bit. So I'll see you in class, Alan. Let's do it. Let's do Everything is Fine. Here we go.